Hey guys, we are venturing into computing probabilities, so let's get going. What do you know? This is an example that I have used for years and now it is more relevant than ever. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking distance learning courses for credit and record the student's age. Here is the probability model. Okay, so one of the first questions you could be asked on a probability question is, show that this is a legitimate probability model. And in order to show that something is a legitimate probability model, you need to show two things. One of them is the sum of the sample space is equal to 1. And the other one is that each probability is between 0 and 1 inclusive, meaning the probability could be 1 or it could be 0. But again, between 0 and 1 inclusive. So first things first, all you would do is you would get your calculator out, your trusty calculator, mine's right here, and you would add up and you'd say, okay, so 0.57 plus 0.17 plus 0.14 plus 0.12, is that equal to 1? In my calculator, it says 1. We are good to go. So all I would do on a test, if this was given to you, I would say the sum of the distribution, let's say it differently, the sum of the probabilities of the distribution is equal to 1. And then if you notice, each probability is between 0 and 1. For those of you who don't know what a sample space is every outcome that could happen for that event or what's going on. So in this case, it's ages of people who are 18 and over who take distance learning courses. So this is every option, which is our sample space, okay? So then we would also say each individual probability is between 0 and 1. Check, check. We have a legitimate probability model. Now, FYI, on a worksheet or a test, you may be asked if it's a legitimate probability model, and you'll notice that a probability doesn't make sense. Like, for example, they might talk about a deck of cards, and they may say the probability that you get a red card is 3/4 and a black card is 1/4. That's not appropriate for an actual legit deck of cards. However, because the probabilities add up to 1 and each probability is between 0 and 1, it's considered legitimate. All right, let's keep going. Find the probability that a chosen student is not in the traditional age group, 18 to 23 years old. Well, there are two ways we could do this. One way, we want to know what's the probability that they're not in the 18 to 23-year-old group. So what we could do is we could use something called the complement rule. In order to figure out the probability that they're not in the 18 to 23-year-old group, we could do the opposite of that. We could say, well, if we're not in the 18 to 23-year-old group, the opposite would be they are in the 18 to 23-year-old group, the complement, okay? So we could do 1 minus the complement to give us the actual probability. So let's write that out. If we wanted to figure out the probability that they're not in the 18 to 23-year-old group, equals 1 minus the probability that they are, are in the 18 to 23-year-old group. Okay, so that would be now again, if you're not familiar with this notation, that just means the probability of something happening. Okay, so the probability of not in the 18 to 23-year-old group is equal to 1 minus 0.57, okay, right? Which is equal to 0.43, okay? That's one way we can do it, is we can figure out probabilities using the complement rule. Another way we could have done this is we could have used something called the addition rule. If we are not in the 18 to 23-year-old group, that means, equals, okay, the probability that they're in the 24 to 29-year-old group, or that means add. Whenever we say or, that means add, so that's what we need to know, the probability of the 30 to 39-year-old group, or the probability of 40 or over. So what we would do then is we would take, well, the probability of 24 to 29 is 0.17 plus 0.14 plus 0.12. Now this addition rule gets a little more complicated, okay? When we're talking about things that are not mutually exclusive, we can just add the probabilities together when they are mutually exclusive. Well, what does mutually exclusive mean? It means it can't happen at the same time. So that means I can't be age 25 and also belong to the 30 to 39-year-old group. That can't happen at the same time. So when things are not mutually exclusive, we just add up those probabilities, and we're going to get more in depth in the next video about that. But for now, what you need to know is, hey, when we are saying or, keyword or, we're just going to add things up. So with the probability we're not in the 18 to 23-year-old group means the probability we're in the 24 to 29-year-old group, or the 30 to 39 group, or the probability of 40 or over. Okay, and we add those up, and that should give us 0.43 as well. Oops, plus, I meant equals. All right, let's move on to the next slide. Here's one. I want you to pause it. You could just try this one on your own just to make sure you have it, and check with me during office hours if you wanted to make sure that you're on the right track. But I think slide one got, it gave you what you needed. So again, here's example 5. Pause it right here. Try it on your own. If you're feeling unsure, come visit me during office hours or at the end of class, just ask. Okay, let's talk about mutually exclusive a little bit more. Okay, so we have two events here. The probability that the person has a cholesterol level of 240 milligrams per deciliter of blood or above, and B, the person has a cholesterol level of 200 to 239. Okay, the probability of A is 0.16, the probability of B is 0.29. The first question it says is, why are A and B mutually exclusive? Okay, so what mutually exclusive is, and we'll type it over here. We already talked about it. Two events can't happen at the same time. Okay. Now in AP Stats, you need to be able to prove that using mathematics. Okay. Well, what is A? A is the person has a cholesterol level of 240 or over. B is the person has a cholesterol of 200 and 239. Well, I can't be in the 200 to 239 group and also be above 240. That can't happen. I can't be in both groups at the same time. So how do I prove that mathematically? All we do is we say the probability of A, okay, right? Forgive me. What we do, so A and B at the same time, we use this symbol. It's called the intersection. And that means and, okay? So the probability that A and B would happen at the same time, that can't happen. So all we do to prove that mathematically is we say is equal to 0. Okay, again, we said for mutually exclusive events, when we want to figure out the probability of one thing or the other thing, we just add them up. So here it's asking for the probability of A or B. So all we would do here is we'd take 0.16 plus 0.9, and we would add that up together, and that's going to give us 0.45. Okay, again, mutually exclusive events, and you're trying to figure out one thing or the other, you just add them up. If they're not mutually exclusive, we'll get into that in the next video. Okay, here it's saying what's the probability that we have a normal cholesterol? So that's something less than 200. Well, what I'm going to do here is I have a sample space, right? And we know that in our sample space, we are either going to have what they consider a normal cholesterol level, excuse me. So that's event C, or they're between 200 and 239. So that's event B, or they're above 240. That's event A. That's our sample space. That's everything that could happen with our cholesterol levels. I want to know what's the probability of C. Well, I can use the complement rule, right? I can say, well, let's take 1 minus the probability that they are not less than 200, and that is the complement. And we say like this. Anytime you see, whoops, forgive me, guys. Anytime you see something to the power C, that means not what you're looking at, okay? So what am I going to do right now? I am just going to take, hey, 1 minus the probability that they're not less than 200. Well, not less than 200 is here. We're either at A or B, which is 0.45. And that's equal to 0.55. Again, another way that we can use that complement rule there. All right, we're done with part 1 of the video. I'm going to move on to part 2 here in a second. So take a break, stand up and stretch, whatever you need, grab some water, quick Snapchat your friends, whatever you need to do. And we will be on with part 2 in a minute.